Good morning, guys. This is Anjani Kumar, leading Power System 2 for third year electrical students from Newton's group of institutions. Till now, we completed the concepts of what are the different types of transmission lines. Till now, what you completed means different types of transmission line. But on what basis you categorized, on what basis we categorized. So there are three basic things to categorize these type of transmission system, based on length, based on how much voltage that can carry, and based on the capacitor existence. So these are the three factors to distinguish the different types of a transmission line. In that there are three types of transmission lines. So what are the two? Short transmission line, medium transmission line, long transmission line. Right? We discussed all these things. What is the length of the long transmission line? What is the length of the short transmission line? What is the length of a medium transmission line? How much voltage that they can carry? Right? What about the capacitance existence? In a short transmission line, you have the capacitance. You don't have any capacitance existence because the length is very small. And medium transmission line, you have the capacitance existence. And medium, definitely we require capacitance. Alright? So basically, if you want to estimate each and every performance of a transmission line, you should calculate the constants of transmission lines. So in order to estimate each and every performance of each and every transmission line, you have to know the generalized constants of a transmission line, so that we can call it as a transmission line parameters. Right? So what are the transmission line parameters? Those are A, B, C, D. We discussed about all these things. So what is the equations? Normalized equation to calculate these type of ABCD parameters means Vs is equal to AVR plus BIR, IS is equal to CVR plus BIR. So these are the generalized formula. So with this you can estimate, you can find out the value of A, B, C, D, and all these things you can calculate it. Right? For a short transmission line, for a short transmission line, so what is the model for short transmission line? We already discussed all these things, but I just want to remind you guys for a brief introduction. Alright, so what is a short transmission line? What is the model the short transmission is look like? This thing. So you don't have any capacitance existence. So this is the resistance, this is the inductance. So this is sending end voltage, this is the receiving end voltage. This is the sending end current, and this is the receiving end current. So this is the model representation of short transmission line. Yes, sir. So we can translate this model of transmission line into normalized form. Now with that you can calculate what is the ABCD constants. ABCD constants. If you know this ABCD constant, these are enough to estimate the performance of a short transmission lines. Right? So after that we already discussed about all these things. We solved that ABCD parameters for a short transmission line also. Right? And the second one is medium transmission line. So medium transmission line. So what is the length of the medium transmission line? 50 to 100 kV. 50 to 150 kilometers, right? Sorry. And what is the voltage that can carry 20 kV to 100 kV? Right? Definitely the minimum length is there. So that's why it is having the capacitance effect should be present in the system. So definitely if you want to estimate the performance of a transmission lines, all the transmission line parameters should be lumped, not distributed. Actually the transmission line parameters are distributed parameters, no doubt about that. In order to calculate that performance of the system, we should consider these type of parameters, lumped parameters. Right? So these type of parameters we can treat it as a distributed parameters. So how we can represent these medium transmission line? So we can represent these medium transmission lines into how many types? There are two models. Two models. So what are the models? First one we can call it as a nominal T method, and the second one we can call it as a nominal pi method. Alright, so nominal T method. How the nominal T method look like? We'll see. How the nominal T method look like? Transmission line which is having a resistance, inductance, and the capacitance will be exist in the midpoint of the transmission line. So this we can call it as a Z/2. This we can call it as Z/2. This we can call it as admittance because it's a parallel path line. This is a sending end voltage. This is a sending end current. This we can call it as receiving end current. So this is a model representation of a nominal T method, and translate this model in the form of normalized equations. You can calculate ABCD constants. What are the ABCD constants and all these things? You will actually we derived all these things. So you just go through my previous lessons. It will be very easier for you guys. So these are very important bits. What are the short transmission? What is A, B, C, D? In the GATE exam, definitely you will get these type of questions. For a medium transmission line, nominal T method, what is the value of B? What is the units of B? What is the units of C? And all these things you will get. Right? And after that, the second one is a nominal pi method. See, nominal pi method. How the pi method look like? The capacitance can be existed from the starting end and what is the ending end. So what is this? So this is a medium transmission line, right? This is a capacitance placed. So this is the capacitance. So this it's look at pi model now. So this is called Z. This we can call it as Y/2, and this we can call it as a Y/2. So what is the sending end? This is a sending end voltage. This is a current. This is a receiving end. This is a current. This is a receiving end voltage. So this is the model representation of nominal pi method. We already discussed what are the transmission line parameters for nominal pi method. We derived ABCD constants. Also with that we can estimate the performance of a nominal medium length transmission lines. And after that, what is a long transmission line? Already discussed it. Medium transmission line. So what is a medium transmission line? The medium transmission line, what is the length? Length should be greater than 150 kilometers. Alright? Greater than 150 kilometers. What is the voltage? Greater than 100 kV. Alright? Greater than 100 kV. Definitely the capacitance existence will be there, but this is not a minimum length. It is greater than 150 kilometers. Means you don't know how much length it is. So definitely you should maintain the transmission line parameters are distributed parameters throughout the length, because you don't have any minimum length. It's a long length, right? Definitely you should consider. So for this we have a method called, what is that method? A rigorous method. Rigorous method we'll discuss in the next unit. All the derivations are for ABCD constants for this. So with the help of rigorous method, you can calculate the ABCD parameters. So how the model look like? We already discussed about the model look like. This is the capacitance. This is the inductance. See, this is the model representation. The n number of divisions we already discussed. XL by n. This is B by n. This is G by n. This is nothing but leakage susceptance, leakage conductance. This is due to the capacitance existence. This is due to the leakage current. R by n, X by n. Under this. So from going from sending end to the receiving end, what is the current of the leakage conductance? Leakage current should be very less. That's why we can neglect them. So you can only take the capacitance effect we should consider. So in the rigorous method, you can easily calculate with the help of rigorous method, you can easily calculate the ABCD parameters of a long transmission lines. Alright. So this is the brief things that till now we discussed about overhead transmission lines. So I think all the students are well about my videos. If you have any doubts regarding explanation and video presentation, right, each and every faculty getting lots of difficult for providing these type of videos, guys, at least you should follow the videos. Try to remind what the faculty said, and definitely you should follow. That's your ultimate thing, right? Today we discussed about what is the voltage regulation of a transmission line, right? So what is the concept of voltage regulation of transmission line? Alright, see, you are in third year, right? So I don't have that much effort to tell the definition of a voltage regulation, right? So you already studied in a transformer, synchronous machines, alternators, and all these things. You'll get these type of voltage regulation concept, right? So what is a voltage regulation? Definition. What is the regulation? Voltage regulation: change in the output voltage from no load to full load. No load to full load, we can call it as a voltage regulation, right? Change in the output voltage from no load to full load, we can call it as a voltage regulation. How the formula for percentage voltage regulation means? We get V no load minus V full load by V full load into 100. So this is the formula for voltage regulation, right? You can make it as V no load minus V full load by V no load also. This is also regulation, right? So which voltage is higher? Under no load, definitely the voltage is higher, na? Voltage is higher. Under no load, definitely the voltage is higher. Under full load, the voltage will be less when compared to the no load voltage. So definitely the voltage regulation is positive here. Positive voltage regulation. So under no load condition, definitely the voltage is very high. Under full load condition, the voltage is very less. When you apply the voltage, definitely there will be a losses. If you load apply this on, definitely if the load is inductance, right, definitely there will be losses. So sending end voltage కంటే receiving end voltage తక్కువగా ఉంటుంది. So that's condition that we are assuming, right? Under no load the voltage is high, under full load the voltage is less, right? So this we can call it as, if VNL is greater than V full load, then we can call it as a positive voltage regulation. So this we can call it as a full load. So what about that no load to full load? Full load heavy. If it is high, what about voltage regulation? Down. So this we can call it as a down regulation, right? So we can call it as a positive voltage regulation or a down regulation. Why we can call it as a down regulation? In denominator part, you are having full load. So full load means when compared to the no load, full load voltage is very less. Sorry. I think there is a mistake is there. The full load voltage is very less. So that means what about the voltage regulation? It should be very high. So this we can call it as up regulation. Sorry. I'll clearly explain one more time. Right? So what is the percentage of voltage regulation is equal to V no load minus V full load by V full load into 100. Or else you can also define V no load minus V full load by V no load also voltage regulation, but you won't consider these type of regulations. That means V no load voltage is very high. if V no load is greater than V full load, we can call it as a, always V no load is greater than V full load, we can call it as a positive voltage regulation. Positive voltage regulation, right? And if V full load is a denominator part, it should be very less. Less means voltage regulation is high. This is called up regulation, right? So depends on the load, my no load voltage should be greater than the full load voltage, right? In some other loads like capacitive loads, definitely my no load voltage should be very greater, very lesser when compared to the capacitive loads we discuss, right? Why these type of regulation will exist in each and every machines, right? Why? The machine which is having a storage elements only, you are getting these type of regulation. For suppose, see, you know about what is the power? Power is equal to V into I, na? Alright? I have a motor, whatever the load, I have a mixie, grinder, whatever it may be, right? So we require a constant power to the device. So this is our ultimate. If you see the transformer from input to output, my power is a constant. So each and every machine, we need to make the power is a constant, right? For this, these two things will make this power is a constant. For suppose I have a mixie, grinder, whatever it may be. So that can run with 5 kilowatts. Right? A mixie or a grinder, whatever it may be, 5 kilowatts. That is the constant power that required for a machine. Right? What about the voltage? So you are giving single phase supply, na? So that is a 240 volts. So whatever it may be. Right? This is a rated voltage. So 240 volts that you are giving. Right? For that the current is going to be developed or increases, whatever it may be. But you are getting 240 volts. Definitely due to that external condition, fault condition, climatic condition, you are not getting 240 volts accurate. So sometimes the voltage must be reduces, sometimes voltage must be increases, right? If the voltage is reduces, what happens along with my current should, if voltage reduces, what about the current should increases to make the power constant, isn't it? If voltage reduces, my current increases to make the power constant. So that means the load should have a constant power, but we are not getting 240 volts regularly. So there may be a voltage fluctuations is there now. You won't get 240 volts directly. That definitely you have a fluctuations. If the voltage is reduces, definitely my current should increases to make the power constant. So it ultimately means to make the power constant, right? My 5 kilowatts, so my power is going to be constant. You are designed that machine with this power, right? So if a voltage reduces, my current increases. You know what about this? If the current increases, my windings get damaged, right? There will be overheating in the machine. My machine will definitely destroyed, right? So voltage is increases, what about the current will be reduces to make the power is constant. So for this, if the current is reduces, you know everything, my machine won't start. So that much current, it doesn't have that much efficient current to start the machine. So these are the factors that affecting each and every machine. So definitely it is possible, it is required to make the voltage regulated. So that's why we need a regulator, we need a regulation. If it is a zero regulation, it's more efficient machines, like a transmission line also. These type of problems. Transmission line which is having a sending end is there, na? Receiving end is there, na? So definitely what is the regulation? What is the regulation means the difference between sending end voltage minus receiving end voltage. By receiving end voltage we can call it as a regulation. Regulation of a transmission line. Same thing, each and every machine, these type of things. Input is there, output is there. You can regulate. So where the voltage regulation, if it is at, I'll clearly explain the concept of regulation in a transmission line. So, right. I'll clearly explain. I started what is a regulation, what is the need for a regulation, we discussed. Actually, what happened in a transmission line, we discussed. So this is a transmission line. Alright, this is a sending end. So this is a receiving end. This is a current IR. This is R XL. So this is a short transmission. So what is the formula for regulation? Percentage voltage regulation, we can call it as a V no load minus V full load by V full load into 100. So this is a receiving end side regulation because you are connecting your load at the receiving end. Alright. So what is a no load? Alright. What is a no load voltage? What is a no load voltage? You know the formula. Vs is equal to no load. No load means my load is open circuit now. If open circuited, what is the current? IR is equal to 0 now. If it is open circuited, load lo current ఏమవుతుంది? Definitely 0. Substitute Vs is equal to, you know the normalized equation, Vs is equal to AVR plus BIR na. AVR plus BIR na. What about that? IR is equal to 0 na. Put IR is equal to 0. Vs is equal to AVR. Alright. So what is VR? VR is equal to Vs by A. So you got VR is equal to VR under no load, right? No load is equal to Vs by A. Now we'll see what is the voltage regulation. You are regulating at your receiving end. So that means VR no load minus VR full load by VR full load into 100. So what is the value of VR no load? So VR no load is Vs by A. You can call it as a Vs by A minus VR by VR into 100. So this is the percentage voltage regulation. So what is the, so you are calculating for short transmission line now. What is the value of A? A is equal to 1. So therefore percentage voltage regulation is equal to Vs minus VR by VR into 100. So this is the formula. So each and every time you are taking a short transmission line for calculation purposes. And once again I'll explain. In a short transmission line, so definitely the regulation should be maintained because you are connecting your load here. Alright, you are connecting your load, either machine, motor, generator, whatever it may be, right? So what is the percentage voltage regulation at receiving end? That means VR no load minus VR full load by VR full load into 100. What is the value of VR no load? You know that normalized equation. Vs is equal to AVR plus BIR. Under no load condition, if you don't have any load, what about the current IR? IR is 0. IR is equal to 0. Vs is equal to AVR. What is VR? Vs by A. VR no load is equal to Vs by A. No load, you are calculating this one. No load means IR is equal to 0. Then substitute here. So VR no load is equal to Vs by A minus VR. So this is the derivation. So you don't tell directly regulation means Vs minus VR by VR into 100. Actually the formula for regulation is equal to Vs by A minus VR by VR into 100. So this is the formula for regulation. So A is one for a short transmission line. So definitely you go for each and every time I'll describe of a short transmission because we are very needed to the distribution system. Like the transmission length is very less when come not that 50 kilometers, less than the 50 kilometers. That's why each and every time we will take it as a equal to 1. So what is the formula? Vs minus VR by VR into 100. So this is the percentage voltage regulation for each and every machine. Let's see. So what is the formula? Vs minus VR by VR into 100. If Vs greater than Vr, so we can call it as a positive regulation, right? This is a positive regulation. That means if you want to overcome this, you apply a negative booster to make this regulation 0. If the regulation 0 means sending it is equal to receiving input ఎంత ఇస్తున్నావు, the same thing you're getting in output, so definitely it will be a more efficient machine, right? See, note it down, each and every time the voltage regulation must be 0 and the efficiency should be 100%. So this is the concept. For regulation 0 means input whatever the amount that you are giving, you are getting at the output without losses. That's not possible, right? If Vr greater than Vs, so we can call it as a negative regulation, right? You should make a positive booster. Whatever the boosters and all these things we'll discuss in a distribution utilization concept. So what can call as a booster to make a regulation 0. So this is the concept. So what is the voltage regulation? Percentage of voltage regulation is equal to Vs minus Vr by Vr into 100. Right? If Vs greater than Vr, that we can call it as a positive regulation, that is called a negative booster to make that regulation 0. If Vr greater than Vs, we can call it as a negative regulation to make positive booster to make that regulation should be 0. Right? Now we'll discuss about for a short transmission lines, what is the regulation value and how we can draw the phasor diagram for a short transmission line. We'll discuss. This is very, very important. So definitely the regulation depends on the power factor of a load. We'll discuss how the power factor changes, about regulation changes and all these things, right? For it, now let's discuss about a short transmission line. Now discuss about short transmission line. Now what is the time? What type of load that you are giving? First you will go for a lagging load. You are at receiving end now. My load is at receiving end now. Lagging load. So what is the fun? What is the lagging means? You are getting inductance or XL. This is Vs. This is Is. This is IR. VR. Right? This is VR. Now, what is the equation? You know, Is is equal to IR na. Same current will flow na. Is is equal to IR na. And what is the loop equation? Plus minus. Loop equation, right? Current will flow like this, minus to plus. What is the Vs? Minus Vs. Plus Is into this we can call it as a or. Plus Is into or plus JXL plus VR is equal to 0 na. So what is the Vs? Vs is equal to VR plus Is is nothing but IR na. IR into R plus JXL. Right? And now we'll draw the phasor diagram for short transmission line. With that you can estimate the what is the voltage regulation, if it is a positive regulation or a negative regulation. With this we'll discuss. So first if you want to draw the phasor diagram, first you have to assume